Here we go, Math 1. Let's take a look at this project that we have. So, here's the instructions. So, we are going to be given a starting point and a growth pattern. Then we're going to model that situation in a story problem, a picture or diagram, a table, a graph, and an explicit equation. Okay? And making sure to highlight where you see that growth, where you see that starting point in each model. Okay. Now, there's some bonus extra credit points if you do a recursive equation as well. Okay. And that should say bonus. Alright, now, there are multiple ways you can hand this in, but for this one, it's simple enough that I would just do on the paper that you can either print off on my website or get from me. Now, if you're going to go to the website to print it off, gotta have the slashes. Here's the website, my.uen.org/221804. Go to the Math 1 tab, and you should be able to find, says something like Math 1 Term 1 Project. Okay? And you can print that off. Alright, now, the other thing you're going to need to do is write about a half page or longer, and you're going to talk about each of these models, what the benefits are, and what the limitations are. Okay? Now, you can write it by hand, but I would prefer that you type it. Okay? You need that, and on that same paper, which you can't, this paper you can get at my website as well, there's this rubric, tells you how I'm scoring. Okay? So, total points of 32. Now, the thing to remember is this project is like a take-home test. Okay? It goes in category as tests. So this can be a way to help your grade because this is something you have time to work on. Okay? So, that's a pretty big deal, so I would make sure to do that. You can email if you have any questions to come talk to me before or after school. I would prefer that you type that paper, but you don't have to. Okay? So, there's the main things. Now, in case you didn't have, if you haven't signed up for this yet, you need to come talk to me. But these are all people and what they've signed up for, their starting number, and their growth pattern. So these are for the starting numbers, and these are for the growth patterns. Okay, so I'll scroll up a little bit. If you need to hit pause, you should be able to recognize your own name. If you've forgotten your name, please talk to your parents about that. I think they can help you out with that. Alright? So I also have this up on my website, and you can, it's a PDF, so you can take a look at that to see what you need to do. Alright? Okay, well, let's take a look at an example. Now, I'm going to choose numbers that are not on this list, so you need to make sure that you're not just copying my numbers, but using this as an example, okay? So, for my starting number and pattern, let's do this. Alright, so we'll have my starting number as 56, and my pattern is going to be subtract 5.5 from previous term. Okay? So, make sure you have, when you're watching this video, I would have my starting number and pattern, a piece of paper out, kind of follow along, and, watch what I do, and then do it on your own. Okay, so the first thing I like to start with is the table. Even though it says number 3 or 2, I can't remember what it is on your paper, but I like to start with the table first. Okay, so remember our starting term is the 0 term. Okay, so the 0 would be 56. Alright, after each part of the pattern, okay, I'm going to apply my growth. And you don't have to go down too far on your table, but just enough. So, I'm subtracting 5.5 each time. Okay, so I'm going to subtract 5.5. So my first term is going to be 50.5. Then I subtract 5.5 again, okay, and we end up with 45. Okay, then I do it again, and I end up with 39.5, 39.5. Then 34, and I can just keep following my pattern, 28.5, 23, and so on, okay? And that's my table. Now, I need to make sure I highlight where my starting point is, so I'll highlight that in orange, and I'll highlight my growth in blue. So my growth, we can see it right here, right? That I'm subtracting as my numbers go down, we're subtracting 5.5. There's my pattern of growth. Okay, and my starting number, I see it right here. That's my start number. The 0 term is my start number. That's why I see them both on the table. Now, thinking about your paper that you have to write, what might be some limitations? Okay, what might be some benefits? Well, thinking about this model, it's very visual in showing us that pattern and showing us what the actual input and output numbers are, right? For my third term, I know what it is just by looking at it. So you can see the benefits are it's easy to see where it starts, it's easy to see its patterns, okay? Very helpful in that respect. A lot of people like looking at tables because they can easily, go down to which number they need, and they can see what's going on right there. Okay, so some limitations could be the method in which we have to make it, right? You have to know your starting number, you have to know your growth. If you don't, it makes it very difficult to do. And another limitation is, what if I'm going down to the 100th term or beyond? Okay, that makes it tough because I have to follow the pattern in order to get there, and that can be a lot of work. So that's some limitations there with that one. Okay. Alright, so we've got our table, we've got our numbers. So now the recursive equation I said was a bonus, but you want to do that one because it's easy to score a few extra points off of that one. Okay, because remember, with our recursive equation, it works just like the table, right? It connects an output to the next output. So in other words, if I'm trying to get the 7th term, how do I get the 7th term? Well, I take a look at the 6th term, and then I subtract 5.5. Okay, so the first thing with the recursive that you need is you need to highlight one of these first numbers. Okay, tell us kind of where the pattern goes. So I either write a sub 0, okay, equals, and our starting number was 56, so I'd write 56 there. Okay, I could also go a sub 1. With sequences, they like to start with the first term, which would be 50.5. Okay, either one of those works. Honestly, I could start with a sub 2 or a sub 3 or a sub 4. Now recall that this stands for an output. This stands for an output. All of these do. That a sub number means that we're looking at an output number. Okay, so in my case, I'm going to start with a sub 0, just because I like that one better. Okay, so that highlights the starting point, right? That's where we see the starting point. Now, it's growing by subtracting 5.5. Okay, now the way I highlight this concept of using the previous to get the next is that this stands in for kind of this guy. We're now saying, well, what if I don't know what term I want? Okay, this is the second part of a recursive equation. If I don't know what term I want, a sub n, how do I know what's the previous term? Okay, if I have this term right here, how do I know what the previous term is? Well, if I look at this, 7, to get to the previous term, can I just go 7 minus 1? That would take me to 6. Now, we normally do that in our head, but if it's n, we can apply that same rule and do n minus 1 would be the previous. The previous to that would be n minus 2, right? 7 minus 2 would be 5, and so on. So we use this concept of to get to the previous one, It's just subtracting 1 from n. Okay? So the way I highlight that, because it's still an output, is I go a sub n minus 1. Okay? So a sub n equals a sub n minus 1. And this stands for the next output is equal to the previous output. And then what did I do with the pattern? Oh, we just subtracted 5.5. So that's where I see my pattern. Okay? Now, there's other ways that you can write a recursive equation. Okay? The other one that we'll tend to use as well, kind of works the same way, would be f of 0 equals 56, and then f of n equals f of n minus 1 minus 5.5. Really the only difference is we use this f in parentheses instead of the a and the subscript, but it's the same concept. Okay? It's the same concept. So just keep writing it with the a. Now some limitations and benefits. Okay? The benefit is we can see the starting number, we can see where our pattern is, we can see that pattern very easily, right? Okay? That's a really good benefit. I see that information right away. Okay? I could make a table very quickly and easily. A recursive equation is very similar to a table. Okay? Because a table is how our mind picks up patterns. The recursive equation models that mindset of previous term, apply the pattern, this is what I get, where did I start? Started right here. Okay? So the limitations and benefits are very similar. So the limitations, once again, is if I want to go clear down to the 100th term, okay, that's going to be very difficult because I would have to find the 99th, which means I'd have to find the 98th and the 97th, and so on. So that's a pretty big limitation for the recursive equation. Okay, that you can't really use it in all situations. Plus, it's just kind of complex looking, not in the idea, but how it looks. Just remember that yours will always have all these parts the same. The only difference is what starting number and what pattern you'll put in there. Okay. So the explicit equation, alright, that's where we're headed next. Now the explicit equation, using our table again, it connects the input to the output. So I'm going to have a variable in play here, okay, and so now it helps me decide, okay, if I know what 6 is, then I know what that's going to be. If I pick number 4, I can go with that, okay, and let me show you kind of how it works. So, I'm going to still use a table to help me. So we know we started at 56. Okay, then what are we going to do that first term? Well, aren't we going to take 56 and subtract 5.5? Well, what about the second term? Well, we start at 56 again, but we're going to subtract 5.5 twice. And 3, same idea. We're subtracting 5.5 3 times. Okay, that's essentially what we're doing, right? For the third term. For the fourth term, we're going to subtract it. That's right, 4 times. Okay, and you can kind of see a pattern going on here, right? And we're trying to remember, connect this to this, input to an output. Okay, so what if I went to the fifth? How many times would I subtract? We'd subtract 5 times. 6, we'd subtract 6 times. 7, we'd subtract 5.5 7 times. So what about n? Well, we'd subtract 5.5 n times. Okay, well, we don't know what n is, so how do we do that? Well, this is where the pattern comes into play. Okay, so I look at this first one and I say that my output is going to equal just 56, right? Then for this number 1, my output equals 56 minus 5.5. But I don't want to keep writing 5.5. So for my second, is there a shorter way I can write minus 5.5 twice? And there is. It's called multiplication, right? Multiplication is simply a shortcut of that repeated addition or subtraction. So it would be 5.5 times 2. Okay, the next one would be 56 minus 5.5 times 3, because there's 1, 2, 3 of them. The next would be 56 minus 5.5 times 4. Okay, that'll get me the same result. So looking at this number 1, couldn't we say 5.5 times 1? And for 0, couldn't I say 5.5 times 0? Okay, so do we see which numbers are the same and which ones are different? So this one, 5, would be 56 minus 5.5 times 5. Then 56 minus 5.5 times 6. Then 56 minus 5.5 times 7. And finally 56 minus 5.5 times n, right? Because each one of these numbers showed up in what we were multiplying by. So it only makes sense that for n, we do that. And that's our explicit equation. Okay, that n stands for an input, a sub n stands for an output. That's how I connect it. Okay, now we could also write it y equals 56 minus 5.5 times x. We could also write it y equals negative 5.5x plus 56, which is that slope-intercept form, mx plus b. It's all the same. Okay, you could even write it f of x equals 56 minus 5.5x. Okay, all those stand in for the same thing. Okay, all of those stand in for our explicit equation. You only need to write one of them though. Okay, now what are our limitations and benefits? Well, hopefully you can see the benefit. That limitation of recursive in a table where we couldn't figure out the hundredth, now we can. 56 minus 5.5 times 100. Okay, do I need the 99th? No. That is a big benefit to this, is that we can see that easily. Okay, another benefit, you can graph with it easily. Okay, you can use this equation. It's more versatile than the recursive. Okay, limitations. Sometimes it's hard for us to see the starting and the growth. Okay, it's hard to visualize just from this equation what's happening, and that can be difficult. So remember, we need to highlight the start and the pattern. So where did we see our start? All these 56s. Where's our pattern? The minus 5.5n. Because, or x. Because it's got that variable tied to it, that tells us that we're going to keep using that, which means it's the growth. So there's our pattern of growth, and there's our start number. Okay, so not too bad so far, hopefully. Okay, hopefully you're able to keep up with me. Alright, now the graph. Okay, the graph, okay, we'll want to, now there's two ways you can think about it. Your graph, honestly, you might want to wait and do it after the story problem. Okay, so our story problem is we've got our starting number, we've got our growth, because depending on what our story says is going to affect our graph. Okay, and I'll show you why. So we need something where we're starting with 56 and subtracting 5.5 each time. Okay, so here's mine. Herschel has 56-inch toenails. Okay, got to start something with something. Okay, his mom is grossed out and he can't get a date for homecoming. He decides to cut 5.5 inches off his toenails each day. Okay, now, do I have to have a question for my story? No, I don't, but if I really wanted to, I could say, how many days until his toenails are normal. But you don't really need a question. But you can if you want to. So you've got to have, I've got my starting point, and I've got my growth. Okay? Now, if we're thinking about this story problem, okay, we need to, first let's go limitations and benefits. Okay, limitations of a story problem. It ties it to a context, it ties it to a real life situation, that would be a benefit. Okay, it puts your numbers, your information in the context of something happening, which for a lot of us can help us understand it a lot better. Okay, the limitations are a lot of us struggle to visualize this, to see this. Okay, which sometimes to help with that we may use a picture or a diagram. Okay, but that's a big limitation, that a lot of people can't understand the information because of all the words. Okay, now this easily jumps to our picture, so I would draw Herschel here. Okay, we should probably put Herschel in some clothes so he's not naked. Okay, pants and a shirt, because he's not going to be one of those guys that run around bare shirted. Okay, not the best at color choices. Red and orange I don't think goes together very well. Wait, he probably should be sad, huh? Because no homecoming date. Sad Herschel. Okay, and we've got his toenails, right? That are 56 inches long. Then each day, for my picture diagram, maybe I would go like this. Each day, and I'm not going to put clothes on the pretend ones, I would then show his toenails getting 5.5 inches shorter. Okay, and I just keep going and show my diagram, okay, or a picture, and hopefully we can see better from this how things are going. Okay, and we can do our picture, our diagram, something like that. Okay, and then he gets back to normal size feet, and now he's happy. And he has a date to homecoming. Yay! Okay, but that picture diagram. So, where do we see the starting point? We see it right here. Where would we see the growth? Okay, we'd see it in every shortened version of our picture. Okay, now some limitations and benefits. Benefits are, it's very visual. Pictures and diagrams are visual. They help give us more information very easily, very quickly, especially from a story problem. Okay, now the limitations are, it doesn't help us a whole lot. It's very hard to draw all this. If you get a very large problem, it's going to take you a lot of time and paper and space to draw those. So they're very cumbersome. It's a good place to start. A benefit is it helps us start getting into a problem. A limitation, it doesn't help us go very far. Okay, so now the graph. The graph is very important to understand and helps us visualize it. But if we have a story problem connected to it, it's going to create some problems, because we have what we call discrete, and we also have continuous functions. Okay, and I'll kind of highlight both of those. And depending on what your story problem says, that's going to affect what you do. Okay, so looking at, oops, too far. Okay, my table is going to be the easiest thing to use to graph with. Okay, so 0, 56. So I've got to go clear up to 56. So let's call this 60. This would be 30, 40, 50, 20, 10. Okay, and then 0. So 0, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, you need to label it. Okay, I should probably label this days, because it's tied to a story problem now, and this inches. Okay, so we start out at 56, so right about there. Okay, is my first point. Then at day 1, we're going to go down 5.5, so about to 50. At day 2, we go down and we get to 45. So day 2, 45. Okay, day 3, 39.5, then 34. So 39.5, then 34. Okay, and so on. And that's probably enough to see my pattern. Okay. Now the question is, could I go into the -1 or -2? Okay, if we just had the equation, just this guy, we would. Okay, and we'd go like this, and we draw an arrow. Okay, because there's no connection to it. Okay, I know that that pattern just keeps going either way. However, because mine is tied to a story problem, think about this growth. When is he going to cut it? Is it going to be cutted? Wow, I can't speak. Is he cutting his toenails continuously throughout the day? Okay, probably not. So, if I were to draw the line, it would represent that he's basically every day a part of the day he's cutting his toenails. So if I went to day 1.5, I could go up and say, yeah, his toenails are a bit shorter now. But most likely, and when you cut your toenails, you do it at one time. So he's going to cut 5.5 inches off at one time. So I really, according to my story problem, I shouldn't connect my dots. Okay, I shouldn't connect them. I should they can keep going. Okay, but I shouldn't connect my dots. Okay, and that's what we call discrete, because there's no in between. The continuous is when there is in between. So you've got to look at your story problem, and most story problems will probably end up being discrete. Okay, now where do I see my starting point? Right here. It's my y-intercept. Okay, where do I see my growth? Well, right here. As I go to the right one, I'm going down 5.5. Down 5.5 to the right one. Down 5.5 to the right one. Okay, that's where we see our pattern of growth. So growth, pattern, and then our y-intercept is our start. Alright, finally some limitations and benefits. Benefits are, it's very easy to understand a graph. You look at it, you visualize it, you know basically what's happening right off the bat. Okay, so it can help us see that. Limitations are sometimes they're difficult to graph, sometimes they're very big and cumbersome. So sometimes drawing the graph makes it difficult. Also, it doesn't, it's easy to visualize, but sometimes it's hard to see what's actually happening because you can't see the numbers so well. Okay, and it takes a little work to actually say, okay, well, on day 5, what actually is that number? Okay, I can kind of estimate, but knowing it exactly can be difficult. So that's kind of a limitation with graphs. People like them because they're easy to see, but if you don't spend the time looking at it, it may not give you all the information you need. Alright, so that's basically it, guys. So good luck with this. Remember, if you get that recursive, you get some bonus points. So make sure you turn in that paper with all the things and the recursive. Okay, that's a big part of that grade. Focus on that first. Okay, a smaller part but still significant is the written piece. And I talked about some benefits and limitations in here. If you can think of others, that's awesome. Put them in. Make sure you get this done by the 19th of October. Okay, and there you go.